The link provided for the download of Tracker takes you to this web page. I do not recommend using it online. I recommend that you download one of these versions, depending on your computer. Windows, recent Mac, older Mac, and Linux. Once you are set up, for example, this particular version of Tracker I'm using, I installed it using Windows and I accepted all the prompts. I said okay to all the prompts. Okay, first thing to do to analyze a video is to go to video. Okay, in this case, it is treating this image as a video, but it will have import here instead of replace. So I'm going to tell it replace in this case. I'm going to choose the video that you are going to use for part 1 and part 2 of the lab. Okay, it comes out like this. Now, first thing that you want to do with a video once you upload it is have a look. Have a look by running it. Okay, there's the video. Now I'm going to rewind and then go frame by frame. Okay, and here in the first frame, they tell us the bed of the truck is 2.21 meters long. And it tells us that the video is 30 frames per second. Both of these informations are important. This one, 2.21 meters long, it is needed for calibration. The 30 frames per second is needed for the calibration of the time. So I'm going to start with the calibration of distances, of lengths. So I click on this icon here, press New, Calibration Stick. Something pops up like this. I'm going to align it to whatever is given in my video for calibration. So in this case is the bed of the truck, so I'm going to place it here. It reads 1 meter, but this one says 2.21 meters. So I come here and I adjust that to 2.21 meters. I don't need to keep that calibration stick showing, so I click here. Okay, the next thing is to set the clip settings. This is the first frame that you are going to start analyzing. This is the last frame. And this is where you input the 30 frames per second. If it is like this, 29.97, don't touch it. But if you have a higher frame rate, like 120, type 120 here. Okay, the start frame, in this particular case, it is given in the lab, but if it is not given, you run the video and you are trying to identify where the motion you are trying to analyze has started. For example, it looks probably here. This one is frame 24. And where does it stop? Probably I'm going to stop reading data here, 39. So I'm going to go 24 to 39. Here, 24 to 39. Okay. Now I'm going to rewind back to 24. I can set up my coordinate frames so it starts exactly where the motion starts. So I can click on this. Okay, the axis in this case appeared all the way here. I can come here and position it here at the start where my ball is. Okay, so we are set. I'm going to hide that as well. And this is my next step, track. I'm going to tell it new point mass. Okay, the screen pops up. I'm ready to start. So I hold the shift key and position, see the cursor changes. Position the cursor on top of where the ball is. And I click. So I kind of identify where the ball is. Whenever I'm holding the shift key and I click on it, the data is added. Now here I remove the shift key. It does not collect data. Hold the shift key and it keeps collecting data. Okay, that's my last data point. Now, just for the purpose of instruction, I'm going to add another data point that's wrong here. Okay, so what I can do when I have something wrong like that, I can click on it and press the delete key. That removes it from the data. Okay, now I'm set. This is what you need for collection of data. One more thing you need to do is come here to the triangle for columns, click on it, and choose the kind of data you are interested in. For example, Vx and Vy. And close. So it shows Vx and Vy. The next thing I need to do is move this data to Excel. So I come here, press Control A or Command A if I'm using a Mac. So to highlight everything, and right click and copy selected cells, full precision. And then I move to the spreadsheet where I need to input data. Okay, this is our spreadsheet. Place the cursor where I want to paste the data and Control V to paste it. Now, sometimes you get something that appears like this, and that's just because the data has too many digits. So you double click at the end here, you move your mouse to where the column ends, so it will change shape like that, and you double click. Okay, here's our data. You are going to need to do some graphs. For example, Vx versus time and Vy versus time. So let's start with Vi versus time. Let's do that one. When I pasted the data, if we look here, it looks like this one is not a correct data point. It does not follow the regular trend. And normally, we have the first data point for velocity not showing up and the last data points. So these are erroneous, so I'm going to delete them. Now, for graphing, I need to select the data for the x-axis, hold the control key and select the data for the y-axis, go to Insert, select Scatter Graph, and I get my graph like this. Usually you would not be interested in title, so we remove it. If you get the data here appearing in scientific format, it's not very useful for a graph. So we go here, Format Axis, a number, and we choose number. And maybe just one decimal is enough here. Then same thing for this one. Format Axis, and we tell it number and one decimal. Another thing you are going to need to do, of course, is add in the axis titles. So make sure you add them, you click on it, and you tell it what that title should be. For example, here time, so T, In parentheses, we put the units. And this one here, it's going to be double clicking, and it's going to be in meters per second. Whenever you expect a straight line, you are going to be asked to do a trend line. So we choose a linear trend line, and we come here for more options and to tell it to display the equation. So here is the equation. If you would like the font to be larger, with the equation selected, Control Shift larger than. Okay, there it's bigger. So that's our graph. If I would like to paste that graph in a Word document, for example, if I'd like to paste this graph in my Word document, I just click on it, Control C to copy, Control C or Command C. I move to the Word document, go where I want to paste it, and Control V or Command V, and that pastes it. There it is. Now, let's go back to the spreadsheet. From this graph, we are supposed to get data. We are supposed to get A sub y and delta A sub y. Actually, delta A sub y, we are not going to really get it from the graph, but we need the uncertainty in the slope. We are going to do that instead of directly from the graph using Excel's linest function. Here is a description of the function. So I'm going to duplicate that process as described there here. We are interested in just A sub y and delta A sub y. Looking back here, they are provided in these two cells. So they are two cells, one on top of the other. So what I'm going to do, since I'm interested only on that, is select two cells, one on top of the other. And then I'm going to come here and click here and start typing the formula. Equal, line, you see it starts popping up. Click on it, it tells me known y's. So I'm going to select the y's, and then comma, known x's, select the x's, and then comma, it tells me true or false, so we'll type true, and then comma, again it asks me true or false, and I tell it true. Close the parentheses, and then this is very important. Notice that the two cells are still highlighted, and I click Control, Shift, and Enter together. Control, Shift, Enter together. There's my data. So this one gives me the slope, and this one gives me delta sub y. Now that we have the data, we need to format it to the right significant figures. Delta A sub y has to have only one significant figure or two, depending on the first significant figure. The rule is here. Now, if the first significant figure is a 1, then we need two significant figures. If it is something other than a 1, like here, it's just one significant figure. So we go here and home, and we set this as a number, and we make it just one significant figure. The other thing that's important, your measurement, in this case A sub y, should have the same number of decimals as the uncertainty. This has only one decimal, so this should have only one decimal. So we do the same thing. So that's my data here. Okay, we need to do the same thing for AX and delta AX. So we need to do the graph. Actually, this one was Vy, my mistake. So we need to do the Vx graph versus time, and we need to do the line estimate equation for it to get the data here. And then for Vx, this we need the average of the values. So we do that by writing equal and starting average. So we select average from the list and then highlight the data we want to average and close the parentheses and enter. That's my average. And then delta Vx should be the standard deviation of those values. So we write equal and then st, choose here the first one, and highlight the data, the same data. And we apply the same rule as we applied here. The first digit is a 1, but once we try to make two significant digits, it's going to become a 2. So maybe in this case, we are going to have only one significant digit as well. Okay, so it came out as 2, so I need to reduce it to one significant digit. And this needs to have only one significant digit as well. Number, okay, there it is. The other data that you are going to need to collect is going to be doing another video analysis here. And instead of tracking the ball, in this case, we are going to track one part of the track. So we start here a new point mass, but in this case, instead of tracking the ball, we are going to track another part of the track. I'm going to select the intersection here between the track and the whiteboard. So we hold the Shift key and we start tracking. Okay, so that's our data. Okay, in this particular case, we are interested only in the horizontal motion of the track. So when I go to columns, I don't need to select Y, but I need to select Vx. Close. So once we added Vx, we highlight the data, right-click, copy selected data, full precision, and we come here. We go to our second tab and paste it and do the same work on it, graph Vx versus time, and do the line estimate to get Ax and delta Ax. Do the average Vx using the average function. Do the delta Vx by doing the standard deviation, and we'll be done with that part. This last part here, it's your own video. You need to toss a ball, preferably something small like a tennis ball. You need to toss a ball and videotape yourself tossing the ball. But you need something for calibration, something that you know the length of. And basically you need that calibration to be at almost the same plane as the ball you are going to toss. You are not going to be able to have it exactly at the same plane, but as close as possible. It can be a ruler, whatever you need to use that you can tape, that you can later on use as calibration. For example, if it is a ruler and the length of the ruler is 30 centimeters, when you go to tracker and add a calibration stick, in that case, when you have the calibration stick showing up here, you are going to need to write 30 centimeters, 0.3 meters, instead of 2.210 meters. Once you do the videotape, you analyze it like we analyzed the ball in the first part. And once you're done with that, you port the data here. You see it looks very much like part 1. So you do the same analysis like was done in part one. That's the lab.